Hey, I'm Scott Allen Miller, and this is Sam IT. In recent news, Solarwinds has been one of the most massive breaches in American technology history. Looking at this, there's a lot of questions, and a lot of them that we can't really answer because they have a lot to do specifically with Solarwinds. But a lot of people have been talking on both sides of the fence about how open source could have or may not have been able to affect how this played out. So first of all, the Solarwinds breach. Who is Solarwinds? Solarwinds is a closed source software maker from Austin, Texas, which is broadly used throughout many different industries, and in this particular case was in use by some really big companies like Microsoft and some really important agencies like the United States government throughout different branches of government. This breach is pretty significant because foreign actors were able to inject something into the Solarwinds product and use that as a backdoor to get into government and big business systems in the United States widely. Right? This is a massive breach. The scale of the whole thing is kind of mind-boggling, and it's one of the biggest things that has been in technology news recently. So that is the news portion of the whole event. But what we're seeing a lot of people mention is, boy, had this been open source, maybe they couldn't have done this. And of course, then the question comes up, and I've seen this a bit, well, is that really true? Open source must have a whole bunch of risks associated with it. It can't be as safe as closed source software because you can't see the code, so you can't do bad things to it. So I'm here to set a couple facts straight and to set some context. First, the context. If we're identifying individual products, right? Let's say Microsoft Windows versus Ubuntu Linux. This is an apples to apples comparison, almost as good as we can get. Both of them are broadly deployed operating systems. They're both used as servers and desktops. They both run on the same hardware. They're pretty good head-to-head competitors where one is closed source and one is open, famously. In this particular case, we're comparing actual products. Which one is more secure comes down primarily to the effort that goes into it, the individual contributors, the managers who oversee the project, the processes that are followed in making the software. The sourcing of the code is simply not the primary factor in deciding what is going to be and not be secure. It may be a big factor, but it is not the primary factor. When we're looking at actual software, we have to look at the actual products and the entire scope of them, not just one artifact of them, like how are they licensed, right? It would be akin to saying, well, expensive software is either really safe or really dangerous, and cheap software is the opposite. That obviously doesn't make any sense. Anybody can make something that's cheap, that's super secure, and then take the same product and sell it for a lot of money. The fact that you sold it for a lot of money does not change its security. It just changes its price. So we can prove with no effort whatsoever that there are artifacts like this that have nothing to do with security. In this case, open and closed source of the software, the licensing model does impact security, but it is anything but the only factor. The problem that tends to come up is when we have these discussions, no matter how illogical and completely insane it sounds, most people take that one of these things is better than the other and turn that into all products made through this process must therefore be better than all products made by the other process. That makes no sense whatsoever. That would be like saying it's cheaper to manufacture in China than in the United States. Therefore, all products in China are cheaper than all products in the United States. The first statement is true. Almost always, China is more cost effective for manufacturing products than the United States. But we understand that when we say that, that doesn't mean that if I make a car in China, that it's going to be cheaper than a cheap plastic toy in America. Obviously, the car in China is still going to cost $20,000 or $30,000 minimum, and that cheap plastic product in the United States is still going to cost no more than a penny or two. We understand that it is equal products are probably going to be cheaper to make in China than in the United States, not wildly different products. So when we talk about that, we know that the product is what matters and that this is just a factor in a much bigger picture. When we are looking at source licensing for products, what we know is that open source is a more secure process than closed source. This means just like it's cheaper to make the same thing in China than the same thing in the United States, generally, that with open source, we can meet or beat the security of closed source for any identical product. Now, of course, nobody ever makes identical products in both ways. It doesn't make any sense, right? Something that is licensed as open source is not closed. There is an argument that you can dual license things. Ignore that. Once you've opened it, the security of being open is there, right? But when we're talking about licensing, we have to look at only the licensing to determine which is better, open or closed. But when we're looking at individual products, we have to understand that it is only one artifact of the overall posturing as far as security is concerned. So, understanding the context, we now can start with licensing, open source is more secure than closed source. This isn't a sometimes, this isn't a maybe, this isn't hypothetical, this is how it is. And I ask you, if this is one of those situations where if you ever get that feeling where, well, it seems like open source must be insecure because, whatever that because is that you're having that feeling about, I guarantee it's because there's something you're associating with open source that is not actually open source. For example, you may feel that open source means free or low cost. That is not true. Open source has to do with the fact that the source, the code used to make the product, is available for inspection. It does not imply that the product is free. It does not imply that a large team of people, or even a team of people, have worked on the product. It does not imply that people on the outside who are not the owners of the project or the company that makes the product are involved or able to contribute code. None of those things are true or implied in any way whatsoever. Open source purely means that the source code is open for your inspection. So it is really easy to see when we look at what it actually means that there's no rational way that open source could be less secure than closed source. With closed source, we have two major factors. One is that there are many fewer people who can look at the code. Just because something is open doesn't mean that people are looking at the code. So that's always a consideration. What if we have a piece of code and nobody's looking at it? Does being open really help it? Maybe. Maybe not, but it doesn't hurt it, and that's important. But when something is closed, we know extra people cannot look at it because it's closed. We also know that when something is open, that there is a market pressure on the vendors and the programmers to do a good job and try to catch themselves with problems early themselves, because everything they do is more exposed. If they were to introduce a bug and have it in open source software, and this happens all the time, it is much more embarrassing when people can see the bug and know exactly what it is. So there's a large pressure from just an emotional perspective to get those things closed, let alone from a business perspective where having something really bad would be quite embarrassing because you can't hide it. Even if you fixed it, someone could go back and look at earlier versions of the code and see what you had done previously. So there's a lot of pressure to not let bugs get in there in the first place, and definitely not to let something malicious get in there. Well, whereas with closed source software, not only do you not have all these people who potentially are inspecting it, but you don't have the market pressure because no one's allowed to inspect it. And if someone did, they did that illegally or under some agreement with you, so they can be controlled and may not be able to release that information to anybody, even if they know something terrible is in there. So you have very little market pressure to actually do a really good job. Not that you don't want to still do a good job, but the market pressure is completely different. No one is checking your code for quality. They're only looking to see if they can catch something that's wrong through some kind of testing that isn't looking at code. There's a completely different approach taken mentally when you know people can't see your code. There's also a lot more opportunity for something to be injected into closed source software because you don't have any way to know or guarantee that there's any number of people inspecting that code. And again, the pressures on the companies to inspect that code themselves are fractional compared to the open source companies. So from both a hard visibility perspective and from a market pressure soft perspective, open source wins in a security posturing perspective dramatically. Is a big, big deal. And the worst case scenario for open source is that there aren't any external actors looking at the software and none of them care. In that extreme situation where you have software that nobody cares to look at the code, but they still want to deploy it, you only, in a worst case scenario, get as bad, but never worse than closed source. And this is one of the really important terms that happens here. Open source is as secure or better, equal or better, never worse. That means that we can always, and the equal is a approaching equal. There's always an argument for why it may be nominally better even in those cases. So we can safely say open source is always a more secure approach. We can also, looking at the big picture, open source is always in the interest of the customer. It is in every way beneficial to the customer to have access to the code. They have more freedom, more protection, more visibility, more knowledge, more assurance, more options. Closed source, the question that always comes up, right, is, well, if open source is so much better, that doesn't make any sense. Why would vendors still do it? Why would they still do closed source if open source is always better? That's missing a couple key points. One is it's better for the customer and it's better for security. Neither of these things are primary concerns to a software company. Some software company somewhere is concerned about those things, but in general, these are not big factors. Software companies, being companies, are primarily concerned with profits, and customer benefit and security are not things that make you profits. You may think that they do because it just seems logical, especially in today's world where security, everybody's talking about security, everyone's concerned about security. No, they're not. It's a buzzword. It's marketing. But when you actually start talking to companies, working with them in an IT perspective, working with them in a software perspective, it's rapidly apparent that very few companies take security seriously, and those that do rarely have the resources to really understand how things like their source licensing is a major factor in their long-term ability to protect themselves. Or they may feel they don't have the resources to make it matter enough to put pressure on their vendors or to choose vendors that work in that way. So at the end of the day, these are not factors. Security and benefit of the customer are not things that significantly bubble up to affect vendors in a negative way compared to the benefits of closed source to the vendor to make it easier to monetize their software. And that, at the end of the day, for 99% of software companies, is all that matters. How are they able to make money on their software? And trust me, I work for a software company. I am an owner of a software company that makes closed sourced software. We don't make it closed source because we think it's better for our customers. We make it closed source because we know it's how we monetize it. It's how we're able to make sure we're able to make money on the software that we build. Now, we try to be secure. We try to audit our software. We try to do a good job. We want to make good products, but at the end of the day, the thing that's driving our decision on that is the exact same thing that's driving Apple and Microsoft and thousands upon thousands of other software companies, and that is closed source makes it easier, or in some cases, is the only way that it's possible for them to monetize the products that they're making. Open source simply isn't an option all of the time. Now, it is generally an option when we're talking about operating systems or hypervisors or databases and other really, really big infrastructure components. But when we get into really vertically focused or really niche software or video games, suddenly open source stops making a whole lot of sense because it just doesn't apply in that way. And the fact that it may be more or less secure may not be very important, whereas being able to make money on a very small number of sales is a really big deal. And it's really obvious as a software company when you start talking about products that may not be incredibly difficult to replicate. If someone is able to get a hold of the code, that there's a really big incentive to protect that code so that competitors are not able to simply take a copy of your code, make your product again, and host it. This is a really big deal in software as a service, and that's where we work and have worked for over 20 years. And in the software as a service world, you'll almost always find that closed source is the standard of the day. And that is because if someone else had access to your code, they would be able to fire up your code, run their own software as a service. And because they never distribute the software, you would never have the ability to look at their code and determine that they took your code and ran there. So even if you had a copyright, there may be nothing you can do about it. Of course, if they ran an exact copy and did no changes, you'd probably figure it out pretty quickly and have enough evidence to bring them to court. But if they made any changes whatsoever, which is really easy to do when your code is open, then doing things where you're not redistributing code at all can make it effectively impossible to do anything about someone copying your code. So closed source becomes a really big deal in the software as a service world to protect how software is deployed. So that is why legitimate software companies all day long are making closed source software, even though it is not beneficial to the customer. And that's not a bad thing necessarily, but as a customer, when you're presented with two options, a closed source and an open source is a big deal. In markets where closed source makes sense, typically there is no open source competitor. The closed source market tends to start to wane and eventually disappear once open source comes into parity with it with features. And this happens more or less across all markets. We have seen it happen with operating systems as Linux and BSD started to come into their own. Pretty quickly, all other competitors started to fade away. It may not seem that way today because in the consumer space, Windows and Mac still play pretty heavily, but in the server space, and if you've had a broad scope of the consumer space, the majority of operating systems have died over the years, and those that are still lingering around are often doing so in some weird open source form and not in their original incarnation. Even BIOS has now been replaced with HikuOS, for example. Windows has an open source competitor coming up very slowly, but it's coming over time. Windows is edging towards open source. macOS is built on open source. And all of the competitors for that, all the Linux and Android operating systems out there are open source. And so we've gone from an operating system market where in the early 1990s, we had potentially zero non-research open source operating systems and no viable open source that you could run in production, to today where nearly all servers are open source and a significant percentage of end user devices, the majority of them are open source, but not the vast majority. And the biggest competitors in the closed source space are built on or heavily leverage open source. So in that space, we're seeing open source take over quickly. We're at a mature step of that process. Databases are just a little bit behind that, but we're seeing that catch up very quickly as well. Just 20 years ago, it was relatively rare to see an open source database in production. Today, it's starting to be relatively rare. It's starting to be a little rare to see closed source databases in production. It used to be that you would be surprised. You're running an open source database in production. Today, you would be shocked to find a company of any size not running at least part of their databases, if not all of them, on open source. Not just the database, but the operating system as well, and possibly a lot of the components around it. So that brings us back to a common additional misconception is if people can see the source, doesn't that make the software less secure simply because every hacker, every bad person, every malevolent actor out there can see the code and use that to learn how the software works and do bad things to it or to people who run it? Yes, that's a legitimate concern in a really kind of weird way. Basically, we're assuming that if we make software and lots of good people look at it, that bad people will then see things that the good people have not seen or fixed and take advantage of that. That can happen. That is a theory, and it does play out from time to time, but it is very rare, and pretty typically the good guys find the stuff first or really quickly once something has been compromised. But more importantly, looking at source code is a really ineffective way of finding vulnerabilities. And this is important. When finding bugs, when finding backdoors, when finding malicious things in your code, looking at code is a really good way to find and fix them. But when you want to do something bad, you don't really need to look at code. You can. And that's where there is a small amount of risk there, but really, really tiny. And certainly in no way does that overshadow all the benefits of security that we get with open source. This is a trivial use case for the bad guys. In closed source, however, we have the resulting binary or executable that is distributed for that software. That is what a malevolent actor is going to, in the real world, look at to try to find vulnerabilities. Because they don't care what the code says. They don't care how the code reacts. And in some cases, what the code says doesn't give them enough information because the compiler may be a major factor, depending, or an additional component of the software, things that you may not be able to see in the code itself, or not have a really good indicator in the code itself. So by looking at the binary and seeing how the executable actually reacts to real world input is actually a better way to test what attacks are going to be effective against that software. And so getting access to the source code, while kind of useful, really isn't in those kinds of ways. So open source remains very, very effective. Now, of course, people say, but if I have open source and I have all these people contributing to the project, surely someone can just sneak code in. That's a real concern if you have a project where random people are able to contribute code. Being open source does not imply that people can do that. That's a totally different thing. That is an open development pipeline with nobody controlling the code being added. There aren't too many projects that do that. There are some, I mean, little tiny projects where people are just doing hobbies. Of course, those are all over the place and you can go contribute to those. But if you want to contribute to a major product, something that people are actually using in production, that's going to be really hard to do because you have to get your code reviewed by people before it gets added to those projects. There are processes. The same as if you wanted to contribute to Microsoft Office. You can't just go write code and throw it to them and Microsoft automatically adds it to the software any more than Linus Torvalds automatically adds anything you do into Linux. In both cases, you have to get someone to accept your changes, review them, and add them to the product. But the difference is, in open source, as we discussed, you have all these opportunities for lots of people to audit that software. And in closed source, while the company could opt to have a lot of people auditing the software internally, they can't possibly get as many people as there are in the general universe. And there's no market pressure to have a large number of people to do that. Now, if you're a company like Microsoft or Apple, you are the outlier and you are giant companies with huge resources, and they do put a lot of people to look at that code. And they do spend a lot of money on it, and they do take it very seriously. But we also know that with all the resources that Microsoft has and all the things that they throw at Windows, for example, that Windows consistently comes up with huge amounts of bugs and backdoors that are being found without access to the code by only looking at the binary that often we find have been in the software for decades. And it's not that that can't happen on Linux, and it's not that it has never happened, but the frequency with which it happens in Windows is so much more frequent than in Linux, even though Linux has a larger deploy base, so there's more opportunities to find something wrong. And with Linux, we're able to look at the code, so there's all these ways to find those bugs that we don't have with Windows, and even so, we're finding them more often with Windows. Now, again, this is anecdotal because we're looking at Windows versus, say, Ubuntu, and it's a product-to-product, not closed to open that we're actually comparing. But in the very largest examples that we have available to us, what we expect to happen, what we can hypothesize will happen, plays out exactly as we think it should, right? Closed source simply makes for a sloppier, less consistent, less reviewed, less audited process, exactly as common sense would dictate. So that is a very long diatribe, but it's something that's really important for people to understand. Open source is a better thing for IT, not for software developers. If you're a software developer, Open source may be good for you, may be bad for you. There's a lot of factors, but as IT, as end users, as the company who may be acquiring software, open licensing is important for us. It is always to our benefit, even if we're not going to read the code ourselves. Knowing that we can read the code protects us in many ways. And we'll talk about some of that in other videos because there's things way beyond security that are important there. And I do want to add one last thing because this does come up a lot. A lot of people ask, well, okay, all these things are fine. We accept everything we've said so far, but let's be realistic. Who's actually going through and reading code? Oh, sure. Someone does sometime. We open up GitHub and take a look at a line of code or two. That's interesting. But nobody's actually reading this code, right? My company sure isn't. This is a myth. In the real world, real companies are actually reading code all the time. This is way more common than anybody wants you to believe because everybody has this interest in promoting closed source software and making open source doesn't make people money, right? It makes a few people money, but in general, open source doesn't make a lot of money. So the people who are financially incentivized throughout the entire ecosystem, whether it's the software vendor, the hardware vendor that's packaging that software, the value-added reseller who's selling you the software, all of them have a really strong incentive to convince you that low-cost or free open source software is dangerous or scary or untested because they're paid solely to convince you that it's not. They're trying to sell you something that is closed. That's their business, right? So listening to them, we're going to get a skewed view because they are incentivized. The IT side of the world, those of us who represent the customers, we're not incentivized ever. In fact, if anything, we're incentivized towards open source because it's lower cost, ignoring the fact that it's better for our companies in most cases, right? It's safer, it's probably faster, we have more protections against vendor problems, right? Ignoring all those things, it generally costs a lot less money to get open source products. That means our budgets go farther and we look like even more of heroes to our companies because we're able to do more with less. We're able to impact our company's bottom lines more, right? So we do have an incentive on the IT side to promote open source, but it's not a financial incentive. It's just a doing a better job and getting rewarded incentive. Whereas a vendor, right, a reseller or whatever, is directly incentivized by being handed money in order to convince the customers, us on the IT side, that closed source is going to be better for some reason. So in the real world, when you talk to giant companies, the US government, the military, Wall Street banks, research firms, Silicon Valley firms, software firms that are not the primary vendors, all of these companies actually have processes for reading code. In some cases, they have humans that do it, sometimes all the time. And there's big companies that do this all the time. Intel comes to mind, right? Intel has a lot of people who are constantly looking at open source code, sometimes contributing to it, sometimes just making sure it does what it's supposed to do. These are really big vendors with deep pockets who have an incentive to work on open source code. In many other cases, they're doing it for security or stability reasons, right? The Wall Street banks are concerned with security, so they put in a lot of effort looking at the code because they want to be safe. They can't trust closed source in the same way. They have to use open source to get the level of trust that they need in many cases. That's why the most critical workloads, whether it's the CIA or a military or a bank, they're always going to, when taking security seriously, they're always going to be on open source because the most secure products are all open source. There's also automated tools. And this is what throws people off. They think, well, okay, so maybe you can make an example where a couple big places throw some people at this. Does that really help us, the little guy? Well, first of all, yes, it does, because that's where some of the biggest bug finds and backdoor proofs that they're not there or fines or whatever, that's where they're happening, is those big investments. But and that all trickles down to us as the end users. But we also have automated tools, and these are being used all over the place, sometimes by those same organizations, but also by smaller organizations who don't have the manpower to throw people at it, but they can throw processing power at it. And in some cases, it's an end user company who just wants their own verification that their code is good. In others, it's research companies or software vendors who want to prove that they have better automated software tools to sell to these other vendors or these other customers. So they're going to run against big open source projects in order to find more things and use that to prove that their software does a better job of catching things, right? So there's a lot of incentive for a lot of people to be looking at that code, and they really do. So in the real world, when you're talking about a big project, now if you're talking about something tiny, some little hobby project with 3 people using it and 1 guy making it in his basement and it's only 500 lines of code, there's every possibility that nobody but the guy who made that software originally has ever read that code. But when we're talking about real projects, things that you would deploy in an enterprise environment, whether it's your operating system or your database or your office suite or anything of the sort, you can rest assured that thousands or tens of thousands, maybe even millions of people or automated tools have actively looked at that software outside of the original vendors who made them. Okay, so this is a lot of potential companies. And that's before we consider things like, let's think about Linux. There's Ubuntu Linux, CentOS Linux, Rocky Linux, RHEL Linux, SUSE Linux, Arch Linux, Debian Linux, Raspberry Pi OS Linux, and countless others deep in. Some of these sponsored by governments, some by giant companies, some by hobby projects, all kinds of different things. They are all digging deep into the code and looking for tuning, mistakes, opportunities, all in what's essentially the same code base. And so there's, unlike say Windows, which has one large vendor that has nobody looking over their shoulder, you have lots of big companies and some small ones all looking over each other's shoulders, all trying to get an edge on the others, but anything that they change gets contributed back to everyone. And so the scope, once you start getting into production level software where open source is competing against closed source, the amount that these little factors matter becomes enormous. And that's why in the real world, consistently, no matter how much we can argue about market pressure or talk about common sense, all of this comes together to, in the real world, when it plays out, we consistently find open source outperforming closed source in apples to apples comparisons for security time and time and time again. And so the answer to the initial question, would Solarwinds, had their products been open source, be subject to the same risks that caused them to be compromised and to cascade down into compromising lots of big additional organizations? The simple answer is yes, open source may very well have protected them in several places along their pipeline. It's not just that you can make sure that the software itself is better. It also gives you the opportunity to compile that software yourself and to run verification checks using hashes against the code to make sure that the code that they say they've checked is the same code that you're looking at. And then it's the same code when you go to compile it. You can use something like an MD5 or a SHA5, is that right? Hash along the way to ensure that your code that you're looking at isn't being modified by someone. And then you, if you need that level of security, you can compile it yourself, taking that risk out of the hands of the vendor. If you're dealing with closed source software, someone like SolarWinds, yes, maybe their code was safe. And maybe they were compromised at the compilation stage where they turn that code into a binary. If that's where they get compromised, they as a vendor may not even have a way to check that the resulting binary wasn't compromised because they never see where the injection took place. If we move that into our own shop, we can be sure that we're the ones taking the necessary precautions, that we're creating a binary that we're confident in. We can create that binary on multiple systems to make sure that it's coming up the same time and time again, to have our own verification steps that go really, really far. We can have other organizations compile the same software in a vacuum. So we know if we're being compromised, they would have to be compromised in the exact same way in order for any attack to not show up as a hash violation. So open source gives us not only all the things we just talked about in this really long video, it also gives us pipeline protection that closed source completely leaves us without. Thank you for joining me. I'm sorry that is so long, but this is something I'm very passionate about, and it is very important to understand. But there is a simple takeaway. You don't have to understand all of the pieces. You simply have to understand that open source dramatically beats closed source when it comes to security, and that source licensing is far from being the only factor that matters in security, and that security is far from being the only factor that matters in selecting software. So while open source is always better than closed source, as licensing goes from the perspective of the buyer, which is represented by IT, that does not mean that we should move everything to open source software. Don't make sweeping generalizations based off of false implications from simple statements of fact. It is fact that open source licensing is better than closed source licensing for the end user. That is essentially indisputable fact. There is no argument against it. All arguments against it are arguments for some other topic with either complete misunderstanding of what the terms mean or just the hope that people don't realize that people are talking about something else. Thanks for joining me. I'll see you next time.
NTG. Secure IT for smart business.